Good day, everyone. So today we shall be looking at conduction of electricity in gases. Conduction of electricity in gases. How can you conduct electricity in gas? Without much ado, let's dive into this topic. Okay, the condition required for one to conduct electricity in gas is very simple. Firstly, that container must have low pressure and high potential difference. For a gas to conduct electricity, then there must be low pressure of that gas in the container that it is, and also high potential difference. And this can be carried out in a device called the cathode ray tube. The cathode ray tube is a device that we use for studying all types of waveforms, such as electric current wave, voltage wave, frequency wave, and so on, amplitude wave, and so on and so forth. So we can also use this cathode ray tube to find out how to conduct electricity in gases. And how does it work? Let's take a look at this video. Look at this video. This video is showing us a cathode ray tube that consists of a cathode and an anode. Now, a potential difference of high voltage is connected to the cathode and the anode using a battery. Now, inside the tube, the pressure of the gas here is the air, has been reduced by using a vacuum pipe to remove it. When that happens, after removing the air in the tube to reduce the pressure, and you've connected the battery, what happens is that some electrons from the cathode begin to flow, and there will be glowing of light. This glowing of light shows that electron is coming from the cathode go straight to the anode, and these electrons are called, they are known as cathode rays. Rays that are coming from the electron are known from the cathode are known as cathode rays, and they are also known as electrons too. So this is how we could see that current is being conducted, because the flow of electrons is actually the presence of electricity. So this is how to verify that gases can also conduct electricity when they are in low pressure and with high potential difference. And then the emission of the electron from the cathode is known as thermionic emission. It's a process whereby electron is emitted from the surface of a metal, this time around the cathode. All right. So, and this cathode ray that comes from this cathode are used for making fluorescent tube, okay, and for display signs. All right. So this is how to verify that gases can conduct electricity using a cathode ray tube. Now let's talk about some of the characteristics of this cathode ray that are known as electron. First of all, cathode ray are streams of fast moving electron like we saw in that cathode ray tube. Secondly, they cause glass and other materials to glow, okay, because of the fact that they are fast moving electrons and they have charges. So they travel in a straight line to show that they are light, okay, but this light in this case have charge. They are deflected by electric and magnetic field. This shows that they have charge. In this case, they are negatively charged. They can ionize a gas, that means they can separate the ions in gases. They will turn a light paddle wheel in the tube because they have mass, momentum, and energy. That's why they can turn a paddle wheel, because there is a mass. They have mass and they have momentum. They are highly energetic particles. Okay, they are full of energy. These cathode rays are full of energy. They can affect photographic plates. They can produce X-ray from high density metals. Okay, we know that X-ray are produced when um, when a metal like tungsten is being connected to a high potential difference. That will be what? Emission of uh, there will be emission of what? S there will be emission of electrons, and these electrons, when they hit the anode, X-ray are now produced from the anode. This is how we use the cathode ray to produce X-ray. When the cathode ray are produced from the cathode, they have a counter with the anode, and when they have a counter with the anode then produces X-ray. Then lastly, they are highly penetrating and can penetrate through metals such as aluminium, steel, and gold foil. So these are the various characteristics of cathode rays that we intend to talk about. All right, now let's talk about another area where we can apply this cathode ray um, as a phenomenon. Now, it could be applicable in a device called a diode. A diode is an actually electronic component that allow current to flow only in one direction. Okay, this is a pictorial diagram of a diode. Okay, let's see how it works. As you see it now, when it works, it only allows current to flow in one direction. Look at it. You can see that current is flowing in one direction, but when you turn it the other way around, the current will not be allowed to flow. So it only allows current to flow in one direction. As you can see it here, on the other side, it will not flow. Now, in this case, you show that it can convert AC current to DC current. And this happens because when you connect a diode to a battery, let's say in this case now, this is a battery. When you connect it to a battery, the electrons from the battery begin to flow, and when it gets to the diode, it activates the cathode. It activates the cathode that is in the diode, and then the cathode now emits its electron and begin to flow. Now, when you turn it the other way around, it will not allow current to flow because the other side is the anode. So when you connect back to the other side of the anode, it will not allow current to flow. And that is why it is said that diode is a non-ohmic conductor, because it does not obey Ohm's law. If it obeys Ohm's law, no matter the direction you point the diode, is going to conduct electricity. But because it can only conduct electricity just from cathode to anode, that makes it to be a non-ohmic conductor, and is as a result of cathode ray, flowing in the tube at low pressure and high potential difference. Okay, so this is how electricity can be conducted in gases using cathode ray tube, and then applying it in the aspect of diode. So we'll be doing the cutting here. Thank you for listening. See you another day.